All right, let's get started. Okay, PS9 is out, and you end of the week. Any questions or problems about that or anything? Yeah.
For working on like the file part, would you say that the pedigree demo is a better comparison thing to look at, or that the existing methods you've already implemented are better examples for like inspiration or whatever?
Oh, definitely the existing methods.
Oh.
So for the mobile, it's the pedigree is the best thing to look at. The thing is, both the pedigree and the mobiles are binary trees, whereas the file system is what's called an n-ary tree. So each level you can have any number of children. So yeah. Any other questions? Okay, so I just want to tell you what's coming up. So here's a calendar. So we're there at the 6th. The PS9 is due here 7th and 8th. PS10 will come out probably tomorrow. It'll be due at the end of this week here. Okay, at that point, we have 2 weeks until Thanksgiving. So from the 14th, when PS10 is due, until Thanksgiving is 2 weeks. And then there's only 1 week of classes after Thanksgiving for the first time in my experience. PS11, the final assignment, will come out next week, say on that Thursday. It's what you'll be doing is implementing a game. It's you may have seen a 1980s game called Asteroids. So that's the game. I'll give you a starting point, and you'll need to add a lot of functionality to it. I've learned from experience that if I give a 3-week assignment, or 2.5-week assignment in this case, and just make one due date, then students don't start until the last week, okay, which I don't want to have happen. And so there are going to be multiple deadlines. So just to give you a heads up, the assignment will come out roughly on the 14th. At the beginning of the next week, let's say it'll probably be on Monday or Tuesday, you'll need to do the first thing, which is tell us whether you're working alone or with a partner. So you need to have that nailed down pretty soon. Okay? The next deadline will be by Thanksgiving. So by this Wednesday before Thanksgiving, you will need to have completed some portion of the assignment, and I'll tell you how much of it. And you'll need to make an appointment. You and your partner, if you have one, will have to make an appointment with a TA to demonstrate what you've done so far. So before Thanksgiving, we want to see that you've made some progress. So that'll be part of your grade. And then the assignment itself will be due on the last day of classes, which is this Thursday. Thursday, December 5th is the last day of classes, or if you want to use a late day, the 6th. Okay? So if you're planning Thanksgiving travel, just be aware you're going to have something to do before you go away for Thanksgiving, namely demonstrate some progress on the assignment. Yeah?
Are there going to be available time slots to make progress with TAs?
Yeah, so what we'll do is take some of the time that we spend on TA hours and set up, you'll be making appointments through Canvas. Yeah, we'll fix that so it's easy to do. Yeah?
When does PS10 come out?
When does PS10 come out?
Yeah, next week.
Probably tomorrow. Yeah?
So for PS11, we just need to show that we completed a portion before that day, or?
Yeah. So there'll be a list of things you have to add to the game. A list of required things, and then there's extra credit if you add other things. So you'll have all those lists. Before Thanksgiving, the demo that you do, we want to see 5 of the list of required things done. So it's not a really long list of things to do, but it does ensure that you have at least started to work on the program before Thanksgiving. Because I just don't want people to come back from Thanksgiving and haven't thought of it yet. So, okay, any other questions? Okay, the Zybook assignments are about to start winding down. I can't remember exactly when we run out of the reading, but keep up with it, and I'll let you know when there are no more. Okay. Any last questions? Yeah.
In the Zybook, it mentions abstract classes in contrast with interfaces. Have we talked about abstract classes?
No, we haven't talked about abstract classes. We will next week. So, I had an uneasy feeling in the lecture on Monday because my main point was I was trying to show you GUIs, but I felt like I needed to talk to you about inheritance and interfaces along the way. And I realized in the middle it wasn't working out. So if you don't understand anything I said about inheritance and interfaces, I understand because it was kind of garbled. We'll do it more systematically next week. The main thing I'm trying to get across to you today to prepare you for PS 10 is graphical user interfaces. And I'll use words like inheritance, and I'll talk about them, but we'll look at them in more depth in the next week or two. Yeah?
Just a quick question. The book talks about another Java UI class called the Java FX. What's
Right.
the difference between that and Swing?
Well, it's just newer.
Okay.
Yeah. So when I first started using Java, there was something called java.awt, Abstract Windowing Toolkit. And that was what people used. Then after a while, they came out with an improved thing called Swing, which is what we're using. And then after a while, they came out with Java FX, which I've never bothered to learn because Swing works just fine for me. Okay. So, I have the tip calculator code here. It's the code that we had when we left off last time with a few changes. I added comments, that's one change. And I made the boxes smaller so it wouldn't take up so much space on the screen. So just to remind you, this is what it looks like now. So you can enter into this, the amount of a dinner check. You want to leave a 20% tip. You hit calculate and it shows you what the total is. If you mess up and enter something that's not a number and hit calculate, you get a message that says bad number entered and you can try again. So a pretty simple graphical user interface. But it doesn't look, it looks kind of weird lined up, laid out like that. So first thing I want to do is to try to rearrange this so that it looks more, at least a little more sensible. In particular, what I'd like to have is sort of, normally I'd like it to be sized more like this, sort of like a calculator. And I'd like to have check and this box on one line and tip and this box on the next line and then calculate on the line and then total on the line. So I'd sort of like to be laid up about top to bottom. And you looked at the lab yesterday some at how you do that. What's the key idea for laying out? What do you use to lay out graphical user interfaces?
Is it like set layout or something?
What's that? Oh, you set layout. Yeah, use layout managers. Okay? So we're going to apply a layout manager here. And before I do that, though, I just want to remind you of the available options. So this is one kind of layout. It's called a FlowLayout. And that's the default. So if you create a JPanel and don't set the layout manager on that JPanel, things will be laid out left to right using a FlowLayout. So you've got a bunch of buttons. They're laid out left to right, and if they don't all fit, then it wraps around to the next line. So that's one way you can lay things out. Okay, here's another way. BoxLayout, you can lay out either horizontally or vertically. Here I'm showing the horizontal layout, and it just puts, this is a JPanel that has 5 things on it, and they're just going down 1, 2, 3, 4, 5. That's a box layout. GridLayout is for laying out things in a grid, obviously. So in this case, I have 6 buttons, and they're laid out in a 3-row, 2-column grid. So all you have to do is, if you create a JPanel, you add the 6 buttons to it. You just say, set the layout to GridLayout, and it rearranges the buttons for you. You don't have to go and place them yourself, which is actually an option. You don't have to use a layout manager. You can place things yourself. Typically, we don't do that. And finally, a border layout. So with a border layout, you've got really 5 regions to put things into. You've got the center region, and you've got north, south, east, and west. The idea is that as you enlarge the window, the north, east, south, and west get whatever space they need, and the center portion gets all the space that's left over. So as it grows, it's the center portion that gets bigger. So that's the border layout. Now, one thing to realize is that every panel, you can have multiple panels that make up an application, and each panel can have a different layout manager. So let's look at an example like Eclipse here. And, well, it's maybe a little bit too complicated. What sort of layouts do you see going on here? I'm not certain that it uses any of those layout managers, but well, let's try this. Let's make this smaller and start to make it bigger. So where does the extra space go? Or if I run it this way. So the menus aren't getting any bigger. This toolbar's not getting any bigger. It's this area in here that's getting bigger. So what you're looking at here is sort of like a flow layout where all this stuff here is in the center and the toolbar is in the north, and there are a few labels down here that are in the south. So did I say flow layout? I didn't say border layout. A border layout is very common. Very often in a program, sort of the main area where you're working will be the center portion, and then there'll be stuff around the edges. So it's something like a border layout. Okay? So back to our program. If I want to lay this thing out like I mentioned, so I want it to be, 1, 2, 3, 4 lines, check, tip, calculate, and total. What kind of layout should I use? I want to lay out these things from top to bottom.
Didn't Box do that?
Okay, box layout will lay out from top to bottom or from left to right. So let's try changing this thing, this tip calculator, so that it uses a box layout. All right, so let's go to the code. And just to remind you what we do, this code here just sets up the application window. So it sets a title. It says when you X out of the window, close the application, and it creates a font that I'm using below. Then I create a panel right there. That's going to be our top level panel that contains everything. To it, I add a label right there. I add the box where the check amount is entered. I add a label that says tip %. I add another text box. I add a button. I add another label, and I add another box. Okay? So what do I need to do to get to use a box layout, to change this so that it lays out completely differently? Yeah?
You write box layout equals like a new box layout, and then you put whatever.
Okay, so I got to create a box layout, and I got to use panel dot it's not called AI. What is it? Panel dot set layout manager. Set layout, and I got to create a new box layout, and it wants to know what thing it's controlling. So that's panel, and then we have to tell it whether to do top to bottom or left to right, and that's a constant. So it's box layout dot y-axis. We'll do top to bottom. So we just make that change, and now it's a different layout manager. So if I run this, there they are laid out top to bottom. And as I, it's giving sort of, as I increase it, it's giving space to the boxes, not to the labels. So the reason we use layout managers rather than just absolutely saying put things here, put things there, is because as the window size changes, the layout has to change. And usually it's easier to let the layout managers do the job than to do try to do a custom job. Well, that's still not very satisfying to see something like that. How could we improve this layout? Yeah?
You can have check in the box in the same line, make it the box for the entry box for the check.
Okay, so I would like the label check to be to the left of the box where you enter the check amount. I really just want four lines in this thing, not 7. So the trick is to use sub panels. So right now we have one panel, we've added 7 things to it. So what I'm going to do here is where it says create and add check label, I'm going to create a J panel. We'll call it check panel. And rather than adding the check label to the top level panel, I'm going to add it to the check panel. Okay? And down here, instead of adding the box, the text field where you enter the check amount to the top level panel, I'm going to add it to the check panel. And then what do I need to do with the check panel? That is what we need to add to the panel dot. Okay, so now when we run it, I have an error. It's my error. Oh. This new J panel should be. Okay, so we get check and label on the same line there. And then as we increase it, and that's looking a little more sensible, that top line right there. Okay? So what we did here is, you can't see it, but this right here, this entire first line is a J panel that contains within it the check and the amount, the check in the box. What kind of layout is this thing using? Is this J panel using? FlowLayout, left to right, because that's the default. And the default is to lay them out left to right and center. Well, maybe the box, no, it centers them. You can also have it smush to the right or smush to the left. They're just options when you create the thing. Okay? So we can easily go and put the other labels into JPanel. So I'll do that here. So I'll copy this. Okay, down here, we're going to create a tip panel. And that. Okay, so that organizes those. And finally down here, we'll call this total panel. All right, I think I did that all right, so let's run it. Okay, and that's looking a little better. It's still, we haven't changed the functionality. We can still type numbers there, numbers here, and calculate and get an answer out. It's just laid out in a little more pleasing fashion. Now, if we drag this, it looks kind of weird the way it's rearranging itself. We could work on it harder. There are ways to, for a box layout, there are ways to control where the extra space goes. There are fixed spaces you can add, or there's what's called glue, which is sort of stretchy parts that suck up extra space. But as long as we, I'm not too worried about that. I'm just trying to get the point across that you can control the way things look with the layout. And the problem of making it look right and the problem of making it work right are two completely separate things. Yeah? Any questions about that? All right, now, I want to make one more change to this. I want to make it so that this calculate button, if I click it right now, I get an error, bad number entered. I'd like to make it so that this button doesn't even operate unless there are valid numbers entered up here in these two boxes. I don't want to even be an option to click the button. I don't want it to be clickable unless we've got good stuff in those boxes. So how could we go about that? Got an idea?
Well, yesterday with Total, we did like an uneditable thing. Did you do a similar thing with
Okay, so yeah, we made total uneditable so that only the program can put stuff into it. And so can we do something similar with the calculate button? So let's go to the calculate button right here where let's see, that's where I add the action listener to make it behave. Let's do calculate button dot set enabled false. So by default, I'm going to turn off the calculate button. It'll still be there, it'll just be grayed out and it won't do anything. So there it is, and clicking on it has no effect. So now what we got to, that's nice, but we've got to find a way to turn it on. We want to turn it on as soon as the user has entered numbers in both boxes. So, got an idea?
Can you make an if statement?
Make an if statement? Well, where would the if statement go? Okay? What's your suggestion?
The set enabled method accepts a boolean. We could potentially make two booleans, one for check and tip, and if has something in check and has something in tip.
Okay.
Put that inside of where the false is right now.
Okay, so clearly what we're going to have to do is every now and then check and see if those boxes have numbers, and if so, call set enabled of true. And if not, we'll call set enabled of false. The question is, the key thing is I said every now and then. How do we know? When do we bother checking to see? How do we know to check whether the user has typed anything? Yeah?
Can you add an action listener to the text?
Okay, so we said add an action listener to those text boxes. Okay, and it is possible to add action listeners to text boxes, just like we add action listeners to the button. But that is only invoked when you hit enter in the text box. But you're on the right track. These GUIs are all event driven. Events happen. Events are things like user typed in a box, or user clicked button, or user moved mouse into button, or user moved mouse away from button. Those are all different events. And there are different kinds of listeners that notify you when events happen. So let's see what we can find. Let's see, we've got tip box and we've got a check box we've got to worry about. So let's go down here and do checkbox.add, and let's see what listeners we have. So I have action listener, ancestor listener, caret listener, and on, key listener. Okay? Key listeners have to do with key presses, when the keys are depressed, when the box has focus. You notice there's mouse listener and mouse motion listener, so we could make things happen when the mouse gets into the button or into the box. We could do things like change the color of the background whenever the mouse goes into a box and revert it when it goes out. Not that we want to do that. But all these listeners are there so that you can arrange to be notified when certain interesting events happen. So I'm interested in key events, so I'm going to do that, and I'm going to ask this object to be notified, this being the tip calculator, to be notified when a key is pressed. Yeah?
Can it also track like what keys are pressed?
Yep. I'll show you how, in fact. He asked, can you tell which keys are pressed? And I'll show you that in a minute. Yeah?
And just to review, this is referring to checkbox. Right?
No, this is referring to the, let's see, this is in the constructor, right? So this refers to the object being constructed, namely the tip calculator object. So we're just saying, it's a little bit circular. The tip calculator object contains a text box. When someone types in the text box, we want the tip calculator object to be notified that typing has happened. Now, why is add listener undefined? Add key listener, what's the error here? It's not undefined. Why is it underlined in red? Yeah?
It's not performing the obligation.
Let's see. It says it's not applicable you can't use it for tip calculators. Okay? In other words, this parameter is wrong. You can't, it doesn't, add key listener wants to get as its parameter a key listener object. It doesn't know about tip calculator objects, right? Add key listener was written years ago, a decade ago or more. So we can't give it a tip calculator object. We've got to give it a key listener object. Now, where have we seen that problem before? With action listeners. We have got to turn so a tip calculator is also a JFrame by inheritance. It's also an action listener because we say so. So let's say that it's also a key listener. So what we're doing is we're advertising to the world, by the way, a tip calculator object will also suffice when you need a key listener object. And that's because of interfaces. Now, you'll notice we got an error there. And the problem is it says key listener cannot be resolved to a type. Okay, we've got to import key listener. And now there's an error here. And it says the type tip calculator must implement the inherited abstract method, blah, blah, blah. So what's going on is, remember I told you last time what an interface is. Fundamentally, an interface is a list of methods. Just declarations, no implementation. And so, for example, in the case of action listener, the action listener interface consists of the declaration of a single method called action performed. And if you want to claim to be an action listener object, you're obligated to provide an action perform method, which we did down here. Right there. If we call that something else, it's not going to be happy up here anymore. It's going to tell you that the tip calculator claims to be an action listener, but does not provide the required method. So let's undo that. And now it's saying the tip calculator claims to be a key listener object and does not provide the correct methods. Now, one thing we could do is go look up what methods that the key listener interface contains and implement them, but it's easier just to hover the mouse here and click Add Unimplemented Methods. So it'll go off to the interface. It will find out there are 3 methods that any key listener is obligated to provide, and we can have it put stubs in for us. So there they are. So now we're good. We are now an official key listener object. A tip calculator is also a key listener because 2 things. It says so up there. It says I am a key listener, and it backs it up by implementing these required methods. Yeah?
Is there a limit on how many things you can extend?
Is there a limit to how many interfaces you can implement? No, there's no limit. So you can right here, you can put as many, you can implement as many interfaces as you wish. You can only extend one other class. You can implement multiple other interfaces. And again, we'll look at more of what this means next time. But the takeaway right now is, if you want your class to be a key listener, in addition to a tip calculator and a JFrame and an action listener, you've got to advertise that claim here, and you've got to back it up by implementing the required methods that the interface says have to be implemented. So now, what's going to happen when someone types into that box, that top box, the check box? Can you look at the names of those methods we just implemented? What's going to happen when someone presses the key X?
Going to get flagged as a key event?
Well, that'll cause a key event. The initial press will call, when the key goes down, the key press method will be called. When the key is released, the key released method will be called. And somewhere in there, I'm not clear exactly where, the key type method will be called. Okay?
What's the difference between key typed and key pressed?
Well, all I can tell you is key pressed is when you press it, and key release is when you release it. And I'm not sure when. I don't know. I'm not sure. Key type is called somewhere in there, but I'm not clear exactly when. There may be some. It may be as simple as some keys don't count as typing. So if you press down maybe the shift key, it probably registers as a press and a release, but not as a key type. It's just a guess, though. So just to prove to you that this works, let's go right here under key press, and I'm going to print out something. We'll print out hello. Let's run the program. Be sure you look down here at the console. So I'll go to check, and I'll type 7, and you'll see every time I type something, and now I'm going to hit backspace. Okay? So we're being notified every time the key is pressed, and we can do something about it. Now this box here, nothing's happening. So what's the difference between those two boxes? Okay, let's go back up where I did this. Where did I do it? Right down here? Okay, I added the tip calculator, which is posing as a key listener, as the key listener for checkbox. I need to do the same thing for tip box so it can listen as well. Okay, now both of them will work. Now, someone asked, can you tell what's typed? And in fact, you can, because that key event tells you what was pressed. Let's see, I haven't used it in a while. Let's do get key char maybe. So the event carries with it information about what just happened. So I'll now run the thing. I need to make this bigger so you can see again. So let's try typing a 7. Okay. So we can tell what's being typed. If I hit backspace, it doesn't know how to print that. Come down to tip. That works as well. Okay, so we've got the plumbing working. The question is, what do we want to do with the knowledge that a key has been pressed? Notice, I don't care about the release. I figure if it's pressed, it's going to get released, and I don't even understand what type does, so I'm going to ignore it too. We have to implement all 3 methods. That doesn't mean we have to put, we can just leave them stubs if we don't want them to do anything when they're called. We clearly don't want to print out what key was pressed. What is it we want to do each time someone types into one of those boxes? Yeah?
You want to update a Boolean that determines whether or not it should.
Right. We want to either enable or disable the boxes. So let's do it this way. I'm going to go copy this. This was the code we wrote that parses the numbers in the 2 boxes and does the math. I'm going to copy it down here and delete some stuff. So I'm not actually going to do the calculation here. I just want to try to parse what's in the checkbox, and I want to try to parse what's in the other box. I don't care about doing the calculation, and I don't care about displaying an error message. But what should we do if there's a number format exception in either the check, trying to convert either the checkbox or the other box? Yeah. We want to disable the what was it called, calculate button? So I'll do calculate button dot set enabled false. Now so far all we've done is add code that disables the calculate button. At what point should we enable it so that the calculation can actually happen? Where can I put, yes?
Right after the 2 parse statements.
Right, we stick it right here. So if the exception isn't thrown, if we succeed in parsing the 2 boxes, then we get to the 3rd line of the code here, and we want to do this. Okay, so it's either going to be enabled if both boxes contain numbers. It's going to be disabled otherwise. So let's run this and try it out. So I'm typing, and nothing is materialized down there. I come down to tip and I type 18. No, that's not quite what I expected. Huh. I practiced this for a class even. Let's see. It's like it's 1 character behind on me. So I think, oh, I see, okay, I remember this now. When I practiced, I made this mistake too. Interesting thought experiment. It seems to not notice, let me show you again what I discovered. I type 1, 2, 3, that's fine. You'd expect that when I type 1 right there, it should activate the calculate button because I've entered a tip amount, but it doesn't activate till I hit 2. What do you think?
Because it's a double, but you're parsing a double.
No, that's not it. It's not because it's a double. Good try though, yeah.
shows you only check it when the key is pressed, because you have to click another key before allow a second again.
Well, it's related to that. So the problem is, I'm doing it when the key is pressed. I'm finding out about the key press before the text box finds out about the key press. So while the key has been pressed, the text box hasn't registered it yet. And so when we go and get the text out of checkbox, that key isn't there yet. So what's the obvious? So it's a timing problem. We need to check what's in the text box after the key has been noticed by the text box. So what can we do to fix that?
Move it to key release.
Exactly. We'll just take it out of here and put it in key released. So by that time, the text box will have registered the key press itself, because it's finding about things in a similar way. So now when I run it, 1, 2, 3, then as soon as I hit 1, it activates the box, 18. If I mess up, it deactivates it. Oh, that's not a number. I delete it, it's good again. Now it's bad again. I put 20 in there, I'm good. I come up here and I type something bad. It gets deactivated, and then I can do the calculate. You start to wonder whether the calculate button's even necessary here. Right? You could just have it anytime there's valid numbers, it can display the total without bothering with the button, but whatever. Okay? So hopefully you're getting the flavor of what it's like to program these things. On the one hand, there's building the view, making it look like you want it to look. That's one problem. And then you've got to take this inner user interface and make it do something. And you do that with listeners. You find out when events happen, when keys are pressed, when the mouse moves, and so forth. Got a question? Yeah.
So all this was done with like 155 about lines of code for something like that simple. Are there more streamlined ways to make GUIs?
Okay, he's asking, are there more streamlined ways to make GUIs? And yeah, I'm not trying for, there are ways I could have made this code more compact. And to be honest, when you create, when professionals create GUIs, they're not creating, especially the part of the code that lays out, that creates the view. They're not doing that with straight code. There are programs called GUI designers that let you just drag things off a palette onto the screen and let me arrange the labels and the boxes the way I want, and it would generate the code for me. So it may not be less code, but less that you have to write. Yeah.
I'm just trying to understand why the key release works, why the press didn't. Because my understanding was that the tip calculator was like slow, that it wasn't getting the press. And to me, it seems like the release would be transmitted even past the press.
Well, okay. All right, so he's asking again about why it worked to use the key released event instead of the key pressed event. So think about it this way. So we have our GUI here, and we have a box into which someone is typing. So let's say someone types 3. So what happens is, two things happen. One, well, this is misleading. Let me erase this for a second. So over here, here we are, our calculator. Here's the box. Over here's the keyboard. And there's the key 3, and someone presses it. Okay? So that information goes to the program that's running, and the program has to do two things. It has to put the 3 into this box here, and it has to call that key pressed event that we create, key pressed listener that we created, that key pressed method. The question is, what order does this happen? If the key pressed event is activated before the 3 is actually put into the box, then key pressed is going to look into the box and not find anything there. It's happening too soon.
Oh, okay.
So
timing was the new
timing, it's not like, it's just a matter of things happen in a certain order, and we ran into a situation where our method was called before the box was updated.
Oh, okay.
And so by doing the key release, the box gets updated before our method gets called.
So it wasn't that the tip calculator was too slow?
You know, it's nothing about it being too slow.
It's
It's too fast, if anything. Yeah.
Okay. By making it an extra step.
Right. But again, the thing you realize is the code that's putting the number in the box is also Java code that we didn't write. So it's just the program racing itself. It just does things in a certain order, and the order didn't work out for us. Any other questions? Okay, now I'm going to look at another example. You got to look at the tic-tac-toe example yesterday in lab, I believe. And that tic-tac-toe example is going to be more applicable to your next assignment, your PS10, than this will be. So let's take a break and we'll look at what we can do about tic-tac-toe. All right, before we look at tic-tac-toe, let's think about Connect 4. So here's the Connect 4 game. So C4 board is the class you implemented. What did the C4 board class do? What was its purpose? Go ahead.
I mean, you may have been to set up the board, but it seemed that particularly it was kind of more like a scorekeeper and kept track of turns.
Okay, so you said it's like a scorekeeper. So it keeps track of the position, how many wins, how many losses, and so on. So it keeps track of the state of a game, of an ongoing game of Connect 4. Did you write any swing code in this class? No. You didn't even know about swing then, at least not from me telling you. So even though this was part of a program that did, graphical user interface, it knew nothing about the graphical user interface. Now the code that I gave you, C4display.java, it has all the GUI stuff in it. If you look in here, it's, you see it's dealing with fonts and JLabels, and they're going to be, let's see, there ought to be a border layout in here somewhere. Oh, that was bad. Border layout right there, because that would be the center portion where the actual game pieces were. And if you made the board bigger, those squares just got bigger. The stuff around the side stayed the same size. All right, so the terminology for this is called a view. So what I did was I divided the implementation of this game into creating a view and creating a model. So you wrote the model, the part that knows about the game, and I wrote the view, which knows really nothing about the rules of the game. It just knows where things go. And then I also wrote some code in the same class here that connects the model with the view. That's called the controller. So, in a serious graphical user interface, the code is going to be separated into a model, a view, and a controller, often in separate classes, so that the classes don't have to know much about each other. What's the advantage of breaking off the model into its own class instead of sort of building it into the view in one class? Yeah?
Just an idea, you could use it in other views?
You could use it in other views. You could decide, okay, I really like the way this thing keeps track of the rules of the game, but I don't like the way the game looks. So you could keep the same model class and create a completely different view. So that's one reason to split them up. So you can reuse either one individually. Okay? What's another reason you can think of why it's good to split the model out? Yeah?
They kind of contain like different types of code, so it's like.
Well, yeah, they do. They contain different types of code, and different people are good at different types of code. Okay? Whoever creates the view needs to be more artistic, perhaps. But what I'm going after here is, if you split them up, then the model can be tested. The problem with GUIs is it's hard to test. It's hard to write unit tests against that tip calculator I just wrote. And the game you're going to produce for PS10, to grade it, the teams are just going to have to play the game. I can't, without an incredible amount of effort, I can't get Gradescope to auto-grade a GUI application. It would have to sort of go simulate clicking things and typing things in, and while that's possible, it's difficult. So splitting has all kinds of advantages. The modularity advantage we talked about, reusability, and being able to test the model separately from the view. So C4 display is not the perfect example of splitting things up into a model, view, and controller, because the controller code is mixed in with the model, mixed in with the view. But it's a reasonable one. What we're about to do with tic-tac-toe is not split up into model, view, and controller. It's all mashed into one class. And okay, so I've sacrificed all the advantages that I talked about, but what do I gain when I mash them all together in one class? Yeah?
I mean, it's easier to see how they all work together.
Yeah, it's a little bit simpler. So if you're talking about a simple graphical user interface program, maybe you don't need this full-blown division into model, view, and controller. Maybe it's simpler to mash them together. The problem is if you try to use that tactic for truly large ones, the simplicity doesn't work for you anymore. It just gets too complicated. You do need to split it up. So when you work on PS10, you have your choice. You can use Connect4 as your model of how to create GUIs and split it up into separate model and view. Or you can use the tic-tac-toe as an example, which is simpler. And what I'm going to recommend is that if you're up for the extra challenge of creating truly separate abstractions, one for the view, one for the controller, for the model, go for it. If your goal though is to keep things simpler, and then use tic-tac-toe as your example. It won't affect your grade one way or the other. I just wanted to tell you why they look so different. All right, here we are at tic-tac-toe. So let's see. This is the code from the lab. I've added a few things to avoid having to type too much in front of you. We'll run it, and that's what it looks like right now. So we've got a view game button, a quit button, then we've got some labels that say wins by X, wins by O, and ties, and then we have a grid of 9 buttons. Probably not the way we want our tic-tac-toe to look. How could we lay this out better so that it looks more sensible as a game? Okay?
Well, I imagine we want the buttons to be the bulk of this window.
Okay.
And just the new games and quit and the wins maybe all at the top, but we want those buttons to be large and basically take up the majority of the square.
So we want the buttons, the 9 buttons, to take up the bulk. So how do we do that? Yeah.
Is it border layout?
That's a classic example of a border layout. So let's go try to set this up as a border layout. So so what I've got is a main method that launches it. Then I've got this constructor which really calls make contents to do most of the work. So here's make contents. It says we create a 3x3 grid of buttons. And let's come down here. We do that. You can notice we're using a grid layout there for the 3x3. That's good. It's on its own J panel. Then I have 2 buttons added to another J panel called controls. That's using a FlowLayout. Then I have a BoxLayout that's organizing the wins and ties. And right here, I add them all to the root panel. So what is it I need to do? Where do I create a border layout? Yeah. What's that? The root panel is what needs to have. Right now, the root panel is using a flow layout, which is why everything's flowing from left to right. So what I need to do is just say, that's not right. Root.set layout, new border layout, and I have to import that. And then when you add, you need to tell it where to add if you're using a border layout. So the controls, we want to go to the center, and we'll put the labels up in the north, and what the heck, where'd the buttons go? Oh, okay. And the grid goes in the center. I had that backwards. So we're just giving it a few hints about where to put things. And now we get that. Not the best looking tic-tac-toe thing, but it'll do. And as we resize it, you'll see that these guys in here get the bulk of the room. So we can make it as big as we want. Okay? That's the first thing. So we've at least got it, we've got the view done, if you will. So any questions about how I accomplished that? I pointed this out before, but I want to put it out again. This is a grid layout. Just the buttons are in a grid layout. They're on a panel by themselves that are using a grid layout. This is a panel that has 3 labels using a box layout. This down here is a panel using 2 buttons and a flow layout. And those 3 panels are what I'm adding right here. So down here I created yet another panel as the root. I set it to a border layout, and then I added 1 panel to the south, 1 to the north, 1 to the center. And then ultimately I return this panel, and it becomes the content pane of the frame in the end. So any questions about that? I'll point something else out. I did not make this tic-tac-toe extend J-frame. Okay? I did that with the other class to show you what inheritance looked like. But instead what I'm doing is I'm just have an instance variable called J-frame, or not even an instance variable, a local variable called J-frame. I create the J-frame, I set its title, default close, and so on. All right, so what should we do next? There it is. Yeah? Okay, say that a little louder.
So register a X or a 0 depending.
Okay, so we need to make it start responding. We got all these buttons here, quit and so on. It'd be nice if we could get them to actually operate. So if we were splitting this up into the view part and the model part, we'd be working on both classes simultaneously. But here we're just going to mix all the code in. Let's do something simple like make the quit button work. Okay? So how are we going to do that? Let's find the quit button. It's right here. How are we going to make it so the quit button actually causes the game to end?
Mouse listener.
Well, a mouse listener is a way, but with buttons there's an easier way to tell if they've been clicked. Action listener. Okay? So what we have to do is we have to give this button a name. Like this. And then we can add it there. And then we're just going to say okay. We've got to add to the quit button an action listener. And it should notify this object that we were invoked on. So it should call the action perform method on this object when it's clicked. And again, it's complaining that you know, if we look at this, it's going to say, I want an action listener, and this is not an action listener. So how do we fix that? We come up here and we say what? We say implements action listener. Action listener. I'll have to import that. And now it's going to tell me, well, you claim to be an action listener, but you did not implement the required method. So we'll ask Eclipse to add them here. It'll show up down here, and there's the action perform method. And so what we'll do is just call system.exit. That just ends the program. So now that should work. We run the thing, we click quit, program ends. Yeah?
Could you extend the action listener, or do you always have to?
Oh, no. Action listener is an interface, so it has to be implemented, not part of it. It can't inherit from it. Okay? So far, so good. Well, how do we make these buttons do anything? Yeah?
Would you create like an action listener for each of those individual buttons, or do you just create one for all of them?
Okay. Well, okay, let's see what we can do. Yeah, we got to somehow do the same trick we just did here. So let's go find where we're creating the buttons. They're being created right here. What if we add an action listener to each one? So to do that, again, I'm going to have to say, we'll create a J button this way. And then we'll say b.add action listener. This. So what's going to happen when one of these buttons is clicked? Let's run the program. What will happen when I click one right here? What method will be called? Yeah?
Is it going to exit?
Yeah, it's going to call action perform. And what does action perform do when it's called? It exits. That's not what we wanted. So we need to make, let me, as an aside here, let me say that there are techniques I could use where I could essentially call a different method for each button. But I don't feel like explaining that technique. So instead, I'm going to have every button call this one action perform method. It's not the best design decision, but given the time I have and what I feel like explaining at this point in the class, it's the best decision. I mean, it's a defensible. Somehow, we've got to decide which button was clicked to decide what to do. Okay? So, how can we hope to know what button was clicked? Yeah?
E probably has some sort of method that
Yeah.
could return what.
E will tell us something about what was clicked. So let's look at it. So we're going to look at E. So there's a method called getActionCommand, and there's one called, I think that's it. So let's use getActionCommand, which I think what it does, no, I don't have to think. Let's see what it says. No, we'll try this out. what was it called? Quit. So if that is that, we will exit. Otherwise, I'm not going to do anything for the moment. So we're only going to quit if the action command, which I think is the same, in this case, is going to be the same as the name on the button, is quit. So let's see if this works still. Okay, so quit still works. But now when I click here, it shouldn't quit. Okay? That's good. What should we do if it's not? So if it's not quit, it must be one of those other 9 buttons. What should we do? Yeah.
Does it have to be content equals?
Say again?
Content equals?
It could be equals, or I'm just getting tired of fighting with Eclipse because every time I want it to do equals, it says content equals. And I'm about to give up on it. Yeah? What's the difference? We'll talk about that another time. It works fine. It'll work fine here either way. Okay? So what should I do if it isn't? Yeah?
Would you assign an X or an O?
Okay. What we need to do is change the button. So instead of containing a number, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's labeled with X or O, right? And to do that, we got to get the button. Well, there's a way. If we do e.getSource, it returns the thing that was clicked on. It returns the object that was clicked on. And so we're going to do this. So it'd be nice if that worked without a red line. What I intended to do was I go to the event and I say, give me the thing that was clicked on that calls this method that you called, and we're going to store it in the variable b. The problem is there are lots of things that could have caused this event to happen. And so e.getSource returns an object. Now, everything is an object. So basically it's saying it returns something. But we have inside knowledge. We know that that was a button that was clicked on, a J button that was clicked on, because those are the only possibilities. And so we can put what's called a cast in. So if Java says this thing you just got is an object, and you actually know what it really is, you can put a cast in and then Java will be happy. It doesn't do any kind of conversion or anything. It just says, you're just saying, trust me, this thing's a J button. Now, if it turns out not to be a J button when the program runs, you'll get an unhandled exception in this case. But we know it's a J button. So that's called a cast. All right, so we got that button that was clicked. What should we do to it? Okay, we just got to change what, so the method that changes what's displayed is set text. Now, I'm going to set it to X for now. We'll figure out how to set it to X, to the correct letter in a minute. Let's just see if this works. There we are. I click there, it turns to X. I click there, it turns to X. So that's good. But they're awfully small, don't you think? Okay? How can we make those things bigger? Right, we've got to change the font. And in fact, I don't like those little numbers there either. So I'm just going to create a J button with no label initially. I'm going to b.setFont. When I create the button, I'll set it to this font I created up here called button font. And if you look, you'll notice that the button font is 60 point, which is pretty large. So we run it. That makes the buttons bigger, so it has room to put the thing. But now when I click, you can tell. Okay? So we're just sort of nibbling away at this thing, bending it to our will. And that's what you'll need to do when you do PS10. Okay? What can we fix next? Yeah?
Could we take stuff from our connect form as far as like keeping track of whose turn it is and stuff like that?
Okay, so I heard someone also say O's. So that's really the same suggestion. If we know whose turn it is, we can know whether to put in X's and O's. So how can we keep track of whose turn it is? Yeah?
An instance variable.
An instance variable, right. So I already created an instance variable here I'm going to tell you about in a second. So I'm going to create an instance variable, private int moves. And that's going to be number of moves made so far. Now, if we were dividing this program into view and model, where would this instance variable belong? In the model. So that's why I say that it's all being mashed together. We've got buttons appearing in the same class with this instance variable moves. But it does make life simpler for you for simple applications. In the constructor now, and that's where should we do this? I'll start adding code right here. We need to set moves to 0. And then down here in the action performed, what should we do to get X or O to appear appropriately? Okay, go ahead.
We should do an odd unit, so you could do like mod 2 is equal to 0.
Okay, so we could say if moves mod 2. So if the number of moves is even, what should we do? No, if 0 moves have been made, it should be an X, right? X is, so even numbered moves, we do X. Odd number moves become O. And what else do we need to do? Yeah, we need to remember we just made a move. Okay? All right, let's see if this is working. By the way, for PS10, there won't be much in the way of tests, obviously, for on Gradescope. The test on Gradescope will just tell you, did you name the class right? So you'll be more or less doing what I'm doing to test it out. So let's see, if I click there, I get an X, there I get an O, X, O, X, O. That's not right. You're not supposed to be able to, that's a different game. Battle tic-tac-toe or something. Okay, so how can we fix that problem? Yeah? Do what? Well, we could do the uneditable, but these aren't being edited. These are buttons, so that actually wouldn't work. I could disable them. But what's simpler? Yeah, we need to check if there's something already there. Okay? So let's just do this. Let's say if b.getText.length, that way we don't have to deal with content equals. So if the button's label is empty, that means there's no X or O there. And we do nothing, else we do that. Okay, so I just put this thing. So if there's, no, that's not right, is it? If there's something already there, do nothing. Otherwise, do something. So let's try that out. So X, nothing happens. And then we do O. Okay, and actually, I'm thinking that there is a bug lurking here. We don't want to count it as a move if we ignored it, right? So I'm gonna do this. I'm only gonna count the move if we actually mark an X or an O. Right? Now I think we got it. Okay. All right. What's next?
Check to see if there's 3 in a row.
Right. We got to deal with winning. Check to see if there's 3 in a row. Okay. So let's see how to do that. So just to give you a hint, I declared an instance variable up here called, it's a two-dimensional array. It's going to ultimately be a 3x3 array of buttons. And I've got some methods down there that will help us if we can arrange the buttons into that array in the order in which they appear. So let's go see where we're doing that. So that's called board. So let's go down here where we're making the contents. So right here, we start laying the buttons out in the grid. Let's also create board. New string, no, new J button. So we're going to make a 3x3 array of J buttons. And I'm going to change this loop. Instead of running this way, I'm going to have it while I is equal to 1, I less than equal to 3, I plus plus. So we're still doing the same 9 buttons. But I'm going to create the button, add it to the grid. I'm also going to add it to our board. So I'm not creating any more buttons. It's just that I'm taking the same button, I add it to the panel for display, and then I'm going to add it to my grid variable so I can access it when I got to decide if someone has won the game. So I sort of did all that fast. I didn't change how the game behaved at all yet. All I've done is set up this array board that'll tell us what the 9 buttons are and where they are. So let me pause there because I don't want to get too far ahead of you. See if there are any questions I could answer so far. The only thing I've changed, if you cut the object open, there'll be that instance variable. Yeah.
Create a board as a new instance variable.
Yeah. So board is what I declared up here. Okay? Because we put the buttons in one place so the GUI can access them, another place so our code can access them conveniently. Now, let's go look at the code that I gave you. I have a method called isGame1, and I'm not going to go into how it works, but basically it assumes that it looks to see if there's 3 in a row right here. So it assumes that that board has been instantiated with buttons, and it uses them. So how could we use this isGame1 method in the, where's my action listener? Down here. How could I use those isGame1 method here? What should I do? Yeah. Clearly, if the game is won, you can't make any more moves. So we want to stop. So where would we go to detect if the game has been won? Let's see. Yeah, the place after we make a move, that'd be a good time to check to see if the game has been won. Okay? So let's try it right here. Now notice we're passing no parameters because it just operates on the instance variables. What should we do if the game is won at this point? Sure. Let's do J option pane.show message dialog. And we'll say X1. Okay, I'll import J option pane. And remember, okay, the other complication is you have to tell it where to display the thing. So we want to display it over this. You know? Component object. Oh. Well, okay, this is always my fallback. If you tell it null, it'll just display it somewhere. Okay. Let's do that. So what we're saying here, if the game is won, then we're going to pop up a message dialog that says X1. And we can do the same thing down here for right here. And except we're going to say O1. Let's run it. Uh-oh. Okay, index 3 out of bounds. Oh, okay. Why didn't anyone tell me I was doing this? What mistake did I make? Yeah, I should go from 0 less than 3. What was I thinking? Remember to always consult. Sometimes this window gets so small you don't see anything in it, but you would save a lot of, collectively save a lot of Piazza questions if you just look in here and see where the problem occurred. So run it again. There it is. So I do X. Okay. Obviously I have a bug in my code. Rats. Okay. I claim that will fix it. We'll see. But I can keep clicking, and then my method that detects wins detected a win, but reported it as a win for O because it was O's turn. How can we stop? How can we make it so that you can't? You're forced. You don't make moves anymore when the game is over. Yeah.
Can you break
Break where?
after X1 or something?
Well, this is just a method that was called. Action perform is called, and we display the message, increment the number of moves. There's nowhere to break from. So what we want to do is make it so if action performed is called and the game is over, then the move is ignored. So how can we tell if the game is over? What's that? Well, we could call game 1 again, but why don't we do this? Let's create an instance variable called game is over. And we'll say if game is over equals true, that means the game is over. So anytime someone wins the game, we'll do that. Anytime O wins the game, we'll do that. And then we just got to declare the instance variable. And we got to come down here and initialize it. And now it should refuse to make moves once the game is over. So we'll click, click, click. It tells us X1. What did I do wrong? I got it backwards. Oh, I didn't ever check it, did I? So I've just got to I need to check the instance variable to make sure. I only do this if the game is not over. So now, good, X1, and it refuses. Great. So just got 2 minutes left, so I'm not going to write any more code. Let's talk about how we can finish this off. What's missing?
Incrementing the wins.
Okay, right now it still says wins by X0. So how would you fix that? Right, we would have to make the label that says X wins. We would have to change this label that says how many X wins, make it an instance variable. Don't get up and leave yet. And update it from that same thing. Okay, what else is missing? I think of one more thing, yeah. Okay, 2 things I can think of. New game, what would the new game method do? So if someone clicks on the new game method, we'd have to add a new, another. If it's quit, do this. If it's new game, do that. What is that going to be? Yep.
So we need to keep track of no moves.
Keep track of what?
Well, if the scenario where the game's over because everything's full.
Well, that's a different issue. What would the new game button do?
Reset to 0.
You reset the number of moves to 0 and clear the board. Finally, how would you detect ties? If the board is full and there's no winner, so we need to check that they've made 9 moves and there's no winner, you declare the tie and mark the game over. So you see where this is leading. See you next week.